Hey, Algebra 1B, this is Ms. Sapp again. Welcome to week 3. This week we're going to be dealing with functions, and I'm going to try to get this lesson done in one video. Okay, so let's start with some definitions first. So the first thing you need to know about is relations, and remember we did these a couple of different ways. We did relations as a set of points. We showed them as a table. We did a mapping, which we'll go over that again in a second, and we graphed them. But a relation is just a set of ordered pairs. All the x values are the domain, and all the y values are the range. So let's just go over a couple of different ways we can do show a relation. So first way is with ordered pairs, and that's what we see right here to start out with. So we have -2, 3, we have -5, -4, 4, 2, 2, -5, and 0, -3. This is a relation. It's just a set of points. It's asking for our domain first. That would be all of our x values. And usually they put a little bracket there. If you can't draw that bracket, it's kind of hard. Remember, you can just do the squiggly line. But I'm just going to list out all of the x values. So the x values we have here, -2, -5, 4, 2, and 0. The range would be the y values. And so again, we'll just list them and see again, I can't draw the bracket there. That would be the y values. Remember, when you see these, first value is x, second value is y. So all the second values are what I'm going to list here. 3, -4, 2, -5, -3. Now, technically, I probably should put those in order. So the lowest number would be -5, and then next we'd have -4, and then -3, and then 2, and then 3. But if you don't want to put them in order, that's no big deal. But that technically they should be in numerical order. Okay, as far as the table goes, all we got to do is take these order pairs and write them out in a table. So -2 went with a y value of 3. An x value of -5 goes with a y value of -4. I'm just taking each one of these different points, and I'm just going to write it here in the table. So then 2, -5. Oh, I skipped one. Sorry. Let me go back. Skip 4, 2. And then 0, -3. Okay, easy enough. All right, now mapping. Remember, with a mapping, we put our domain values, which is our x, right? And then our range values over here, which is our y. So I need to go back up. And my domain, let's see, let's put them in order. I didn't do that, did I? So -5 really should come first for the domain. -5, then -2, then I saw 0, 2, and 4. So this is just taking all of, let me change colors here and see if that helps. All of the x values, what I said was the domain, and I put those here. And I just put them in numerical order. Okay, I'll do the same thing for the range, and we already put these in nice numerical order here, so I'm just going to take these values right here and drop them on down to the range. So we have -5, -4, -3, 2, and 3. Now, of course, what's right to the left doesn't go with the right. -5 was not with 5, so I've got to map that out. So let's go back up to these points. It's a -5 went to -4, so I'm going to go back down, and at -5, I'm going to draw an arrow to -4. -2 was with 3. So I'll draw an arrow from -2 to 3. 0 was with -3. Sorry for all the up and down here. 2 was with -5. So all the way up there at the top. And then 4 must have been with 2. Let's make sure 4 is with 2. Okay, one thing you can look for too when we're looking at this, and we'll get to this in a few minutes, is whether or not it's a function. And remember, as long as every x value only has one y value, that is, as long as no x value is repeated as a function, and that is the case here. For a graph, you would just graph each one of the points. So like -5, -4, you would go left 1, 2, 3, 4, 5, and then down 4. And I've already graphed these points for you. There's the first one. That point right there, that's -5, -4. -2, 3. So 1, 2, and then up 3. That point right there is -2, 3. 0, -3. So it's 0. I don't go left or right, but I go down 3. 2, -5, 1, 2, and then down 5. It's right there. And then 4, 2. So right 1, 2, 3, 4, and up 2. And that's how you graph it. So generally when you're looking at relations, they're shown either as ordered pairs, x comma y, or listing out a list of domain and a list out of range. Technically, we should put these in numerical order. A table where we have all our x values on the left and y values on the right. A mapping where we take the domain in order and the range in order and then show lines connecting the x value to the y value it goes with. And then a graph. Okay, now we're going to talk about domain and range here, and these are the ones that are a little bit difficult. So when you're looking at a graph and you're trying to decide the domain, remember domain is the what values? It's the x values, right? And range is the y values. Well, x is going left to right. So what I want to do is I want to take my pencil and I want to start at the left and go to the right, and let's see, where does this graph start? Well, as I go from the left and I travel to the right, the graph doesn't really start until right here at an x value of -1. And every other x value is greater than that. So my domain is actually x is greater than or equal to -1. For the range, and I'm going to change colors for the range. So for the range is y values. So as I go up and down, do you notice how this keeps getting wider? It's covering all of my y values. So my x values were left and right. And left and right, I didn't start having x values to right there as I went left to right. So from here and everywhere over, starting here and over, that's why I said x is greater than or equal to -1. But on the y values, it's really happening all over the whole graph. And so remember, we call that all real numbers. And we can make the funny R with the 2 parallel lines and then draw the R. All right, let's look at the next one. So on the next one, as I look at the domain is left to right. As I go left to right, does it ever stop? No, I've got a graph everywhere. There is an x value for every part of this graph. So the domain in this case is all real numbers. Range, that's up and down. And if I look up and down, it doesn't start until right here, and everything is below that point as far as the range is concerned. Now, range is in terms of y. So all my y values are at 1, 2, 3, 4 or less. So y is less than or equal to 4. So when you're looking for domain, it's left and right, what x values are being used. On this one, the x values did not start until -1, so that's why I have my domain starting at -1 and being everything bigger. Over here, my x values, I had an x value everywhere. It was an x value in every point, so it's all real numbers. Range is y values. Here, I've got y values at every point, so it's all real numbers. But here, I don't have any y values above 4, so all my y values are at 4 or less. All right, let's try it again. So here, on this one, if we go left to right for domain, remember domain is left to right. Again, do we ever see the graph stop from left to right? Well, no, I can see an x value everywhere. Domain is all real numbers. Okay, range is up and down. Do I see the graph stop anywhere? I mean, I can find, at every y value, I can find part of the graph, can't we? So that's going to be all real numbers as well. Okay, last one of these. So here on this last one, domain. Domain is x values, so it's from left to right. Well, where does it start on the left? Well, that's the lowest point on the left, and I got a highest point on the right. It actually stops. When this happens, when it's between two values, you're going to put your variable in the center. Again, it's domain, so x is the variable. You're going to use your signs. It's always a less than sign. The lowest number goes here, and the highest number goes here. This is kind of like those and inequalities we did last week. So the lowest x value is -1. The highest x value is 1, 2, 3, 4, 5. For the range, if we go up and down, well, that's the highest and that's the lowest. Again, range is in terms of y, so I'm going to put it in the center with my less than signs. The lowest y value I have is -3. The highest y value I have is +3. And that's your domain and range. Okay, now let's get to what is a function. Okay, so we've done function a couple of different ways. We look at the actual points and make sure that no x values repeat. And then the other way that we can tell if it's a function, remember, again, you're looking to make sure that no x values repeat. And the easiest way to see this out as a graph is to make sure it passes the vertical line test. So what the vertical line test was, remember, if you draw a vertical line, it should only touch the graph once because it should only have one x value. The x value should not repeat. A function is a special relationship between values. Each input, that's x is always your input, has exactly one output, which is y. Now, can our y's repeat? Sure. We don't care about y when we're talking about functions, but x's cannot. So let's see if we can determine which of these relations are functions or not. All right, so let's look at the first one. So if it's a graph, we got to do the vertical line test. So what I do is I take my pencil and I just start drawing vertical lines. Well, right here, okay, it only touched the graph once, so that was not a very good vertical line, was it? All right, let's try to do better here. What about here? Well, now I got a problem because it's touching it here and here. It failed the vertical line test, didn't it? So this relation is not a function. If I have a set of ordered pairs instead, what I'm going to do is look at the x values. Again, do I care about the y's? Nope. Y's can do whatever, but I do not want any x's to repeat. So I have -4, -2, 1, 2, and 5. Did anything repeat? Nope. So we are good. Yes, this is a function. If it's a mapping, again, we do not want x's to repeat. And the way that looks on a function and a mapping of a relation is we should only have one arrow going from each of the x values. So -3 only goes to one value. -1 only goes to one value. 2 only goes to one value. 4 only goes to one value. We're good. This is a function. Now, if you noticed, I had 2 y values, didn't I? But again, remember that does not matter. Okay, what about this last one? This last mapping. Is this a function? Well, let's make sure we only have one going away from each x. That's only one up, but look, -1 has 2 y values. This is not a function. Ooh, sorry about my handwriting here. Okay, last thing we're going to talk about is function notation. So function notation is a quick way to evaluate functions for a given input. And all you have here of a function notation is you're putting f of x in place of y. It's the same thing. If you see y equals 2x minus 8, that's just an equation of a line. F of x equals 2x minus 8 is still just an equation of a line. All that's there for is to let you know what are you evaluating the function for. For instance, in this example, I have f of 2. Well, this is saying, okay, take the 2 and plug it in everywhere there's an x. Well, in this function, there's my x. So I'm going to leave the 2 alone. I'm going to input this 2 into x and then minus 8. This is still 2x minus 8, but I have inputted a 2 there. And I can just use order of operations to solve it out. 2 times 2 is 4. 4 minus 8 is -4. And I have evaluated this function using function notation. So let's practice using function notation. We're not going to do all of these. We'll just do a few. So let's look at this first one. So we have f of x equals 2x squared plus 4x minus 9. And I'm evaluating it for -8. That means everywhere I see an x, and I got 2 of them, I'm going to put a -8. Everything else stays the same. So the 2 times x squared, well, that's going to be -8 squared, plus 4 times x, well, that's going to be 4 times -8, and then minus 9. Order of operations tells me I want to do exponents first. Now notice I am squaring a negative. -8 times -8 is going to be positive 64. Okay, so I'll just rewrite the rest of this. Next with order of operations is multiplication. So if I say 2 times 64, that's going to be 128, plus 4 times -8, that's -32, and then I have minus 9. Now, if all I have left is addition and subtraction, I can just start from the left and move to the right. So 128 plus a -32, that's like subtracting 32, right? So if I have 128 minus 32, well, that's going to take me back to what, 98? Nope, 96, sorry. That's what I get for mental math. Hold on 1 second. So 128 minus 32 is 96. Get my pen to work. And then 96 minus 9 will take us back to 87. And that's your final answer. Okay, let me know if you have any questions this week. You are going to do your worksheet on functions and turn it in through Teams. And you can always message me through Teams or through